Now let's have a look at the statistic and specifically hypothesis test. So in this question, we have Fia who owns the forest, and in the beginning of the question, we are told that the height of the tree is normally distributed with a mean of 360 and a standard deviation of 27. Now, in part B, we need to do hypothesis test. Fia claims that mean height of the trees in her forest is different to the usual height because they have become infected with a disease. She picks 100 trees at random from her forest and measures their height. The mean height of this sample is 350. Test the hypothesis at 5% level of significance that the mean height of the trees in the forest is different to the usual height of 360. The null hypothesis is given below. State your alternative hypothesis, state your conclusion, and give a reason for your conclusion. A lot to unpack here. Now, one thing that we have to understand when it comes to the hypothesis test, and that's kind of a full name, hypothesis test at 5% level of significance. So this test have few elements, and that's what we are having here. There is a null hypothesis, which is given to us. There are alternative hypotheses. Then there is a conclusion and reason for our conclusion. Okay, so how do we solve it? Well, before we go on to solving it, we have to understand that hypothesis test is about that we have the information about the whole population, and then something happens and we take a sample. There it is. That's our sample. And therefore, we are doing the test to see if the results of the sample are influencing, or can we extrapolate, or can we say that the results of the sample are actually applicable to the whole population, that something have changed with the population. Now, the null hypothesis will always say nothing changed. So in this situation, we are saying that the mean height of the trees in Fia forest is 360. Now, the alternative hypothesis, all it is saying, stating the opposite. So that means that the mean height of the trees is not 360. So that's all what the alternative is. It doesn't give me alternative number. It's just saying that it's not what was in the null hypothesis. Now, we need to do calculation here. How do we do this calculation? So depending on information provided, we have different options with calculation. Now, let me get that information for you. So these are the options, depending on what information are given to you in the question for the calculation. If you are given sample mean and standard deviation, you have two options to go. You can either use the formula to create 95% confidence interval, or you can use the formula for the z-score and test the results against those two values. If you are given population proportion, meaning out of 360 trees, or out of a sample of 100, 10 are short, right? That will be population proportion. And here we have a formula to use and we create confidence interval. Now, only something to note, both of these formulas are not in your table. You have to know them. That formula is in your table, but not these two. Now, in our situation, we do have what? The mean of the population, standard deviation, and we have the sample mean. So the sample mean, so these are our options. That's the information given to us. Therefore, we have two options to go. And here I am going to use both of these options to solve the question to show you how they work. So if it is the z-score, so that means the z-score in our case, the sample mean is 350 minus the mean of the population 360, standard deviation 27, and n stands for the number in the sample, in our case is 100. So when we put that in the calculator, we press equal, we get that z is minus 3.70. Now, how do we test it? We test it against these two values to see if our z-score is within those two or is it outside. And yes, you are very right, it is outside that value. If it is outside that value, whether on this side or this side, we reject the null hypothesis. If it is outside, we reject. If it is inside, we fail to reject the null hypothesis. Now, I got the missing part of the graph. So that's what I'm saying. If the number from our calculation falls within, whether it is those two numbers or within confidence interval, we fail to reject the null hypothesis. But if it falls outside, we reject the null hypothesis. Okay, so our own falls outside, therefore we reject. What about if we use this formula? How will that work? So here the sample mean, again, 350 plus minus 1.96, multiply standard deviation of 27, and number in the sample, it's 100. Now, we put that in the calculator with plus and minus, and we get the two value, 344.708, and then 355.292. So this is the height of the tree. That is that confidence interval. What are we testing against that interval? Is the population. How come population and not the mean? Because that mean, that sample mean, stands in the very middle of our calculation, because on one side we took away margin of error, and on the other side we added that margin of error. So what we are testing is 360, and again 360, that is outside of our interval. So again here the same conclusion. If our number falls outside, which it did, therefore we reject the null hypothesis and we accept the alternative hypothesis. So that is part of our reason, so the calculation. And then for the reason we are saying, if we are using that, we are saying as minus 3.7 is outside of those two numbers, therefore we reject the null hypothesis and accept the alternative. Or if it is the confidence interval we use, we will say as 360 is outside the confidence interval, we reject the null hypothesis. And therefore conclusion, our conclusion, depending on whether we rejected or not rejected the null hypothesis. Because here we are rejecting the null, we are accepting the alternative. In conclusion, we will say therefore, and then we will quote the mean height of the tree is not 360. Yeah? So, like I'm saying, calculations are not that difficult. It's more of a little bit of writing. What is difficult to remember those two formulas because they are not in your table.